Okay, this is going to be the completion of the IA exam. This is a free response question, so it's a little different in your approach in that you want to kind of put down as much stuff as you know, but you don't always have the solutions to check. So like this problem here, if it's multiple choice, my suggestion was just check the answers would work, but we don't have anything to check with, so we have to go through the algebraic thing. So our first step would be to get rid of this 4. The absolute value is going to be an issue when we know that means we have to write 2 equations, but I can't do that until I get rid of this negative 4. So my first step would be to add 4 to both sides. Minus 4 plus 4 cancels, and I have absolute value of 2x, that's absolute value of 2x plus 5 equals 7. And now to get rid of the absolute value sign, I'm going to write 2 equations. And let's think about the meaning of this, first of all. This means basically this entire thing here could be the same thing as 7. So that would be 2x plus 5 equals 7. Or this entire thing could be equal to negative 7, because if 2x plus 5 were the same thing as negative 7, that would be negative 7, absolute value of negative 7 is positive 7. That's why we write one with a plus and one with a minus. So we have to have the absolute value by itself for that to work. Now what we've done is taken a complicated Algebra 2 problem, turn it into a 7th grade problem. So now I'm going to add 5 to both sides. So 2x equals, well, excuse me, I don't add 5 backwards. Let's back that up a bit. Be careful now. We're going to subtract 5 from both sides. Sorry about that. 2x equals 2, x equals 1. That's going to be one solution. Subtract 5 from both sides. 2x equals negative 6. Negative, oh gosh, listen to me. 2x equals negative 12. I'll get this right. Now I divide both sides by 2, x equals negative 6. So there's 2 solutions. Now with any absolute value sign problem or square root problem, we certainly want to check to see if those answers work. So let's do that. We're going to plug these numbers in. So first I'm going to check to see if 1 works. So that's absolute value of 2 times 1 plus 5 minus 4 equals 3. 2 plus 1 is, 2 times 1 is 2, 2 plus 5 is 7, absolute value is 7, minus 4 equals 3. 7 minus 4 equals 3, that's correct. So this is one solution. Now I'm going to check check negative 6. So absolute value of 2 times negative 6 plus 5 minus 4 equals 3. Absolute value, this is going to be negative 12 plus 5 minus 4 equals 3. Negative 12 plus 5, I'll write it over here. Absolute value of negative 7 minus 4 equals 3. That's going to be 7. Absolute value of negative 7 is positive 7. 7 minus 4 is 3. That works as well. So there are 2 solutions to this problem, 1 and negative 6. And you need to have both of them. Okay. How do I get to the next problem? Okay, the next problem involves a lot of interesting things here. We got multiple foiling to do, basically. So I'm going to first figure out the top of this thing here. So if I take the top, I'm just going to look at this. I'm going to say square root of 5 times 3, that's 3 square root of 5. Square root of 5 times square root of 5 is plus 5. Negative 2 times 3 is negative 6. And negative 2 times square root of 5 is minus 2 square root of 5. So the top of my fraction now, let's simplify that, is going to be these 2 numbers combined to be negative 1. And these 2 numbers combined to be plus 1 times the square root of 5. So that's the top of my fraction. This entire thing here is just that. So I have negative 1 plus the square root of 5 on the top, and the bottom is 5 minus the square root of 5. Now I still have square roots in the bottom of my fraction. I want to get rid of those. So the method we learned to do that was to multiply top and bottom, excuse me, not like that, is by the conjugate of the bottom. So the conjugate of the bottom is 5 plus the square root of 5. So 5 plus the square root of 5. And so now the top, when I do FOIL for the top, negative 1 times 5 is negative 5. And then that's that. And I go here, it's going to be minus the square root of 5. And then these two is going to be plus 5 times the square root of 5. And then the last two, square root of 5 times square root of 5 is 5, plus 5. That's the top of my fraction. The bottom of my fraction is going to be 5 times 5, that's 25. Then it's going to be plus 5 square root of 5. And then minus 5 square root of 5. And then minus 5, because the square root of 5 times square root of 5 is 5. So the top of my fraction now, let's simplify that. Negative 5 plus 5 is going to cancel. So I have negative 1 square root of 5 plus 5 square root of 5 is 4 square root of 5. And the bottom of my fraction, 5 square root of 5 minus 5 square root of 5 cancels. 20 minus 5 is 20. So it says simplify, and we have done the major part of simplifying, but we didn't finish because 4 over 20 can be reduced to 1 over 5, so it's the square root of 5 over 5. So this would be the final answer we're looking for. All right, next problem. Determine the value of n in simplest form. Okay, to do that, I'm going to figure out what I to the 13th is. And I think for myself, 13 is the closest multiple of 4 that's below that is 12. So I to the, this is the same as I to the first, which is just I. I to the 18th, the closest multiple of 4 to 18 is 16, and this is 2 more, so it's going to be I to the second, which is negative 1. I to the 31st, the closest multiple of 4 to that, close to that, is 28. So that becomes I to the 28th. So that becomes I to the 28th. So that's like I to the third, and I to the third is negative I, and then plus n equals 0. So that's what the equation becomes. Many of you got to that step and then stopped, but I minus I cancels. So I have an equation that says negative 1 plus n equals 0. Some people stop there. They're saying determine the value of n. Means get n by itself. So I have to add 1 to both sides. Plus 1. That's not an n. Plus 1. And then I get n equals 1. And that would be the answer I'm looking for. We need to put that in there. So that's what they're saying. Determine the value of n is the same as solve for n. Get n by itself. All right, next problem. We've got a couple more to go. Solve this leaving in simplest radical form. There's a couple of ways we can try factoring. That's not going to work. Let's do complete the square. So I'm going to subtract 6 from both sides to start with. This isn't the right number to complete the square. So that cancels. I have x squared minus 8x, leave a space, equals negative 3. A lot of you got to this point and didn't know what to do. We have to put a number here that's going to complete the square, meaning it's going to be half of this number, which is negative 4, squared. Negative 4 times negative 4 is positive 16. So in this spot, I'm going to put plus 16, which means over here I'm going to put plus 16 because now they have to balance. So this becomes parentheses x minus 4 squared. Half of this number goes right there. And half of negative 8 is negative 4, not plus 4, negative 4, equals negative 3 plus 16 is positive 13. And now I'm going to take the square root of both sides. I'll take the square root of this side here and the square root of this side here with a plus or minus. So that becomes x minus 4 because the square root of a square cancel each other out. X minus 4 equals plus or minus the square root of 13. I have to add 4 to both sides. Add that to 4. X equals 4 plus or minus the square root of 13. That's the answer we're looking for that one. If you wrote 4 plus the square root of 13, and 4 minus the square root of 13, that would also be correct. That would work too. All right, 2 more problems. For this problem, again, it's a solved problem. In multiple choice, I'm going to suggest we plug numbers in, but we have nothing to plug in, so we have a little more work to do. So for this one, we're going to subtract 3 from both sides. So I have the square root of 5 minus x equals x minus 3. And now we have to square both sides. So I'm going to have a square root here. To get rid of a square root, we're going to square it. But I have to square this entire thing like that. So that becomes 5 minus x equals, when I square this, I get x squared minus 6x plus 9. You can check the FOIL if you want. X minus 3 times x minus 3 is going to be this one right here. So now I'm going to add x to both sides. And I got 5 equals x squared minus 5x plus 9. And now I'm going to subtract 5 from both sides. 0 equals x squared minus 5x plus 4. And that can be factored to x, and looking for numbers that multiply to 4 and add to 5. That's going to be 4 and 1, and they're both the same sign. They're both negatives. So now that means either x minus 4 is going to be 0, in which case x equals 4, or x minus 1 equals 0, in which case x equals 1. And just as we always do with square root or absolute value problems, we've got to check to see if they work. So let's plug in 4. 5 minus 4, square root of 5 minus 4, plus 3 equals 4. Let's check to see if that works. Square root of 1 plus 3 equals 4. 1 plus 3 equals 4. That works, so 4 is a solution. But when I check 1, I get 5 minus 1 plus 3 equals 1. That's going to be square root of 2 plus 3 equals 1. Square root of 4 plus 3 equals 1. 2 plus 3 equals 1. It does not, so this is not a solution. So 4 is the only solution to that problem. And now the last one that we're going to do, this looks really complicated. People got all messed up with it because all these words, electrical current, voltage, amps, and the bottom line is this is our equation right here. E stands for voltage. It tells you that right there. I stands for impedance. Z stands for impedance. Tells us that. Impedance Z. Current, where do we have current? I'm back up. Hold on. Let me back that up. Z in ohms. Okay, what do we have? Current is I right here. Current is I. Right, I covered it up. I was trying to find it. Okay, the current is I. So basically, E is the voltage. It says a circuit has a current of this. So this number is current is I. This is I. Impedance is that right there, and that's going to be impedance is Z. And we want to know the voltage, which is E. So E, which is considered voltage, equals impedance I, which is 3 plus I, times, 2 letters next to each other is multiply, times the impedance, which is negative 2 plus I. So basically it comes down to do FOIL for that. So I'm going to look at this and I'm going to say 3 times negative 2 is negative 6. 3 times I is plus 3I. Negative 2 times I is negative 2I. And I times I is plus I squared. So that becomes negative 6. These two combine together to be plus I. And then this is going to be plus I squared, which is minus 1. So negative 6 minus 1 is negative 7 plus I. And that would be my final solution to that one. Okay, hope this helps. Thank you.